when we talk about the high-rise building, as I said to you, we are talking about different hazards, different risks in different locations of that building. And all these risks and these hazards have been defined by the industrial standards. You can see here, for example, the nomenclature OH1 to OH3. This means that we have here ordinary hazards, and all those standards that you can see in the red cells, they are demonstrating a source of the guideline and related laws and regulations, how you could design your water mist systems. In NFPA, we have the NFPA 750, which is a standard on water mist fire suppression systems. This standard covers not only the high pressure, but also low and middle pressure water mist systems. In that standard, they talk about light hazards, or which examples for light hazards are, for example, areas like offices, smaller healthcare facilities, churches, schools, and so on. And then you go to the OHs, ordinary hazards, from 1 to 3, 4. The higher the number becomes, the more dangerous and risky in terms of fire it becomes. Just examples for OH1, we could, for example, say mechanical plants, laundries, food processing facilities, and so on. When we talk about the OH2, then we can say, for example, distilleries, barns and stable, dry cleaners, libraries, machine rooms, auto repair shops, and such things. And OH3, or in other standards like FM, they call it also HC3, hazard category. We can count examples like car-sized vehicle repair garages. Then we have, for example, cross-docking areas, aircraft hangars, battery stations, solar plants, wind turbines. All these areas are examples for districts. So we don't have all those mentioned things in a high-rise building, but in a smaller scale, you can have different risks and types. And the most important thing for you to know is that you can connect all those different risks in these different levels of the building and locations of the building. You can connect all of them to only one unique high-pressure water mist fire suppression system by means of separating these risks with the suitable section valves, the high-pressure valves, and also with the separate piping and nozzles inside those rooms. So this is the whole about it. So you avoid, or you save money on the side of selection of different types of the suppression systems. Yeah. And then one of these applications would be a hotel. And in this case, I would just like to show you the Hotel Alsik in Denmark. This is a hotel which is very impressive. This has been finished in 2019. And this hotel had to fulfill the requirement of the ministry to be a zero, a project zero. They call it project zero. So it is, this building is up to 76% carbon neutral, means that the elements and the materials that have been used inside this building are mostly made of carbon free ingredients. And this building has a height of 70 meters, something about 230 feet. The total area of this hotel is 24,500 square meters approximately. We have up to 190 bedrooms inside. We have restaurants, spa areas up to 6,000 square meters area, only the spa areas, and different locations. So all these risks that I have mentioned, or all these areas, they have their particular risk. And the big challenge was, on the one hand, to pay attention to the glass facade portion that you have here. So in terms that if fire breaks out, these glass facades need to be cooled down in order to avoid any deformation. So this is one thing that was very important to pay attention to. The next thing was the limited space for pipes and nozzles and water reservoirs. So the high pressure water mist was the perfect advantage of that to do that. And last but not least, also the challenge here was to avoiding contamination, yeah, because our pumps, as Ken mentioned, they are oil-free pumps, yeah, so we don't use any oil as lubrication stuff, and so the water which comes out of the nozzles, it'll be always a pure water without anything which could cause any contamination. And what we have installed there with our partners, HPP has supplied 5 PAH80 pumps, means 4 + 1. 4 pumps out of 5 were the main high pressure pumps for covering the fire risk, and the 5th pump was a backup or a redundant pump, in order that if one of those 4 pumps is out of order, the 5th pump jumps in and maintain the necessary flow rate or water demand that is needed. These pumps deliver a pressure up to 120 bar and a flow rate of 160 liter per pump per minute.